In this video I'll talk a bit about the geometry plotting capabilities in Serpent. I'll start with the basics so that also first-time Serpent users can get something out of this demonstration, but I'll also cover some new features implemented in version 2.2.2 that was published last week. So the geometry plotter in Serpent works by taking these two-dimensional slices across the geometry. These plots are defined by the plot plane or the plot axis, which is perpendicular to this plane. The routine will loop over the plot plane and color each pixel according to the material at that location. By default, these plot planes are aligned along the main Cartesian coordinate axis, but as I'll show you later, the new features in Serpent 2.2 also allow rotating the axis using some coordinate transformations. The plot is defined by this plot input card, and the first argument of the plot card is the axis, and the axis takes values 1, 2 or 3 corresponding to the x, y and z directions, and the corresponding plot planes in these cases are the yz, xz and xy planes. For reactive physics calculations, probably the most common alignment is 3, which gives the horizontal slice through the core or a single fuel assembly. Other mandatory arguments of the plot card define the size of the image in pixels, so this simple line here produces this kind of standard 500 by 500 pixel geometry plot of the geometry. The colors that you see here in the plot were sampled randomly, but you can also override this random sampling by setting this RGB parameter in the material card. This example here is a PWR MOX assembly with 3 different types of fuel rods, and we can set the colors here so that the colors of the fuel materials so that they reflect the plutonium content, and we can also give some more descriptive colors for the coolant and cladding. One thing to note about using these RGB parameters of the material card is that they also override this automatic coloring of depletion zones. So if you have a burn-up calculation with some subzone division, it may be better to not use these RGB values for these materials so that you can check that this division looks as if you would expect. So in this example here, all of these fuel rods are treated as separate depletion zones for burn-up calculation. The plot input card also has 5 optional arguments that define the position of the plot plane along the plot axis. So for XY plot, this would be the vertical distance from the origin. This position is automatically set halfway between the geometry minimum and maximum, and for two-dimensional geometries it doesn't really make any difference because the model is infinite in the axial direction anyway. The following 4 arguments here define the plot area on the geometry coordinates. So by setting these values you can zoom into the details of your geometry, and by default these limits are taken from the outer boundaries of the geometry model. The plot card also has a lot of other functionality, as can be seen in this input description in the Serpent wiki, and this card has been around since the very beginning of Serpent development, and it has had a lot of new functionality being added to it over the years. And the result is that it has this very complicated input notation with things like 3-digit numbers to override the axis arguments to accomplish different things for plotting the material or cell borders, for example. And we decided to make things a bit easier with this new update and implement this new and alternative version of the plot card called gplot. So both these cards, they use the exact same routines, but the difference is that the input syntax is different. The old plot card still works for producing these simple plots like what I showed just before, but in this new card you also have a lot of additional capabilities with much easier user interface. And in this new documentation, these sort of advanced features are only described for this gplot card. The idea is that instead of listing all these arguments one after the other, the gplot card has these different parameters that are all optional, and the basic functionality that you can also accomplish with the plot card uses these x and pix parameters, which define the plot axis and the image size in pixels. So these two notations here are equivalent. There's also the pos and box parameters that can be used to set the position of the plot plane on the plot axis and the limits of the plotted area. So with these four parameters you can effectively accomplish the same thing as using the old plot card. One new and convenient feature with this new gplot card is that you can now specify just one dimension of the image size. So you can set either the width or the height of the image in pixels, and the other dimension is scaled automatically based on the aspect ratio of the plotted view. And this feature was implemented because with the old plot card you always had to specify the image size to match the aspect ratio, and this would very easily lead to these distortions. So in this example we have a hexagonal VVER 440 fuel assembly that has been forced into a 500 by 500 pixel plot. You can see that the image is sort of stretched in the vertical direction. But with this new gplot card you can specify the pixh parameter and set the height of the image to 500 pixels, and the width is then scaled automatically so that the aspect ratio is preserved. Another feature that is now more easy to access is the control over which boundaries are drawn in the image. So the options are cell boundaries, material boundaries, or both, or you can leave the boundaries out completely. The plot card also has a capability, but with this gplot card you can set this with the bow parameter with much more simple syntax. And as you can see here, when we plot the cell boundaries, this option also draws some additional structures like the lattice cell boundaries here. The new gplot card can also be used for plotting these importance meshes with improved syntax, but this is a topic that I will cover on another video about the variance instruction capabilities in Serpent sometime in the future. Two features that are completely new with this gplot card are these file and name parameters. So the file parameter allows you to specify the file name for the plot, so that instead of writing the PNG image in files with the default formatting, you can specify the file name here. The name parameter defines a unique identifier for the plot, which can then be used with geometry transformations. So the idea is that the transcard also has a new type called GPL, and this enables you to couple the transformation to the geometry plot. And with this new capability you can do things like rotations of the plot plane. Now of course, like rotating this XY plane with respect to the Z axis doesn't really give you any new insight into the geometry, but the main reason for implementing this feature was that when I was working with this LDR50 district heating reactor that has heat exchangers inside the reactor pressure vessel, and the heat exchanger units, they are positioned in such way that the vertical plot planes just got between these units without showing anything that's inside them. Of course it's possible to just shift or offset the plot plane by some distance to show the crosscut through the heat exchanger shells, but I felt that it should also be possible to orient the plane in such a way that it cuts through the center of the geometry and also through these shells. And by rotating the plot plane you can do just that. One thing I want to show you real quick is something that's been around in Serpent for some time now, but not really documented, so all users may not be aware that this even exists. And this is the text-based based interactive plotter. So if you run Serpent with this command line option -IP, what you get is this text console where you can then write plot commands, and the produced PNG file is then updated correspondingly. The idea here is that you have the image open with some image viewer, and I'm using the gnome viewer in Linux here, and every time you enter a command you can see that the image is then updated accordingly. The interface itself is pretty much self-explanatory, and you can get the list of commands by typing H and enter. There's also some description now in the new user documentation, so this is something you may want to check out. So that's all I had for this video. Next time I'll demonstrate mesh plotting and some new features that are available in 2.2.2 for producing these mesh plots. At the moment we're also working on some new things like this interactive plotter GUI. There have been some attempts to develop also GUI based plotters in the past, but what's new here is that this interface will be integrated into the Kraken framework, which has sort of native support for Serpent. And as a final teaser, I also want to show you this one image. So what we're also working on is 3-dimensional plotting capabilities, and this example here shows the Stanford Critical Bunny, which is this CAD based model that we've been using quite a lot for different kinds of visualizations of new geometry types in the past and so on. And I also showed this same model at the beginning of this video, but that visualization was done using Blender. This one here is from one of these first tests that we did using the Serpent geometry routines to do this ray tracing or ray casting to produce this image. So if everything works out, this is something that may be available already in the next code update. Thank you for watching.